more friend for you guys in the classroom. You guys can say hello to her. Her name is Sanvi. This is her first class. And for Sanvi, I would want you guys to be I would want you to be aware of the fact that when I'm teaching things, I'm focusing only on concepts. So you don't have to worry about taking notes and everything, because everything that we do is getting recorded there, and you will be able to watch it later to revise. So focus on understanding the concepts. Everything else is there for you to revise. Okay? Okay. All right. So see, in this classroom we have only girls in the classroom. 5 girls now. Wonderful. Including Myra. So on screen we have Arav, Advik, Deekshita, Shaurya, Vasundhara, Sandrine, Suleen and Gayatri. So what are we going to learn today? And that is not a question. I have sent it. So we'll talk about basic formulas for area and perimeter of shapes, or formula for areas and perimeters of basic shapes. Then we'll talk about the understanding of volume, and then we'll try deriving the volume for rectangular prism and right cylinder. And then we will go into building the understanding of statistics. So Sunny. Okay. So whatever I said that might have sounded a little cryptic to you guys, forget about it. So Sanvi must be thinking, what kind of funny teacher I'm dealing with. He's saying I'm teaching something and forget about it. And that is the thing. We will make sure that we learn things in an easy way, more fun way, so that it stays with us. If you guys learn with a lot of stress, it's easy to forget. Now, Myra, I need your help. I want you to go and turn off the light, this light, because it's reflecting here on the board. This might not be able to see it. Can everybody see the board okay? Okay.
Yes, sir. Yes, sir.
So, first thing first, I will make some basic shapes on the board and check if each one of you are comfortable with those shapes, their properties, their basic formula for finding areas and perimeters, because that will be our building block for going to volume. This is one thing I am poor at, which is called drawing skills. So bear with me. Some shapes might not look like the way I call it, but you'll have to believe me for whatever I name it. Okay? What all you guys see on the board? Triangle?
Rectangle. Height or rhombus.
Rhombus or diamond, whatever you call it.
Square or circle.
Square.
And circle.
Circle. Everybody agrees to what Sami said?
Yes, sir.
Now, is it okay or very hot inside? Magical? It's hot? No? It's hot. Or else you guys can get it closer to you all. So, we are the shapes. Now if I say what is the area of these shapes, do you guys remember the formula for area of these shapes? Let's look at one by one. This is triangle. What is the area of the triangle? Yeah, Deekshita.
Half times base times height.
Half times base times height. And again, just to recollect, area of any shape means the space that object takes on the surface where you are trying to draw it. Right? So this is a bigger area, smaller area. This is needing more area, this is needing less area. So area of any shape means the space that it takes. Okay. If I say, can 200 kids sit in this classroom? Sanvi will say you are joking, because the area or the space that we need for 200 kids has to be much more than what we have in this classroom. Right? So area is the space taken by any object on the surface. Let's say if everybody is taking this much space on the surface, can I make 200 students sit in this classroom? No ways. Yeah. Are you okay? Okay. Everybody okay, right?
Yes.
So forget about this area for now. So I'm just trying to help you guys recollect what is the formula for area of different shapes. Area of a triangle is half into base into height. Meaning, if you consider this as a base, from here to here, this is your height. If you have the base and the height, you multiply this and you get the area of the triangle. If you treat this as a base, you will find out this height from here to here. If you consider this as a base, you will find out this height from here to here.
Sir,
Yeah?
for the second one, when you said if you consider the others, like the side as a base, how come you only made it into the middle, the dotted line?
No, so one more time. See, this is my triangle, okay?
Okay.
There is no side that is given a name base. If I am looking at here, from here, this is my base on which this triangle is built, and this is my height. Okay?
Yeah.
Now, I became a lizard and climbed this wall. And from this wall, I am looking at this triangle as with this as a base. So I am climbing up the wall, and from there I am seeing it. Okay? So from there, this one looks like a base to me. What is the height? This height. From here to here. The lizard moves this side. Yeah? Now this is the base. What is the height? From here to here. Yeah? Yes, Arab. You are seeing a bald lizard right now?
So you're saying that like all triangles have the same side, but what if the triangles are not equilateral?
I never said this is equilateral.
Are we still the same base?
No, it's not the same base. I am saying, see, my triangle could be as skewed as you can think of. Now, it will not give you any impression of this being equilateral for sure, right? It doesn't look like equilateral, correct? So, if I am treating this as a base, if I, let's say this is 8, this is 7 and this is 3. If I use this as a base to find out the area, I have to find out this height. So half into 8 into this height. Okay? Let's say this is h1. This will be 8 into h1. If I treat this as a base, meaning I am hanging from there and looking at this as a base, okay? What will be the height? This is the height. Area will be half into this 7 into this height. Let's say this height is h2. h2. If I treat this as the base, meaning I am looking at it from this side, this is 3, half into 3 into this height, which will be from here to here, this whole height. Let's say this is h3, this is the h3. Funny thing is, this value will be the same. Meaning, regardless of where you are looking at it from, the area or the space taken by this triangle is the same. So, how you are calculating doesn't really matter. What matters is your area will be the same. The space that this guy is taking will remain the same. Is it making sense or not?
Yes, sir.
Sandrine Saling, Saurya, Vasundhara, Gayatri. If I get this many likes on my Facebook post, Facebook will start paying me money. Alright. Thank you. So let's move on. So basically what I was trying to emphasize is that if you look at a triangle, area of a triangle is half into base into height, and there is no side called base. Whichever you take as a base, you have to find out the corresponding height. If you take this as a base, you have to find this height. That's all. Yeah. So, Andy, am I going the okay pace or am I just speaking too fast? It's okay. And again, for Sunday, this class is meant for making mistakes. Be as confident as you can be if you are making mistakes. What happens if I say, can you solve this? Kids will say, okay, I solved this, but I think my answer is this. No, you don't say I think. Your answer is that. Right or wrong, we'll figure it out. Okay? So don't worry about any answer being right or wrong. Lasya laughing at it, Adya laughing at it, me laughing. Nobody laughs at anything. Okay? This is your answer. Done it. No question about it. Yeah? Arya, you don't laugh at anybody's answer, right? See, nobody laughs. Alright, so this is the triangle part. This is rectangle. Area of a rectangle is? Do I need to ask?
Length times width.
Yep, everyone knows? That's your knows? I am asking all these questions for a reason, okay? I know these questions have no weight. They have no value. You guys know it. I know you guys are 10 times more intelligent to be able to give this answer, okay? I'm asking for a reason. And you will appreciate that once I come to that. Now this one, the tricky one. Who remembers the formula for area of a rhombus?
Half times base plus base 2 times height.
Arav. Tell me.
So the over into the paragraph will be based on type.
Sorry.
I'm not sure, but is it G1 times B2 divided by 2?
Bingo. You won a jackpot today. No, I'm just kidding. No jackpot for the students. Okay. So, this is something that we have done in the previous class and we can do it again in near future. Area of a rhombus. Rhombus is a squeezed square. You have a square, you squeeze from two corners, it becomes a rhombus. All four sides are same. Area of a rhombus is half into D1 into D2. The D1 and D2 are the length of the diagonals. This is D1, this is D2. Okay? And we have proved that and we'll prove it again. Not today, but we can prove it anytime. Don't worry about it. Because any formula that I am giving you guys, we looked at the formula for area of a triangle in the previous classes. We saw it, how and why this is to be believed. Right? So, we have proved these formulas also, we can do it again. Whenever you guys are excited to look at it. Now this is square. Again, area of this thing is nothing but length into length. Right? Everybody knows? Area of a circle is pi times r square. Everybody remembers it? And this was
How do you write
this one pi r square. Pi, this is pi. Pi is like we all know 1 is 1, 2 is 2, 3 is 3. Pi is also a pi. It's also a number. It's a fraction that is given a name pi. Okay? 22/7 is given a name pi. This number was coming into play so much so that the mathematician said, okay, fine, I'll not call it 22/7. I'll call it a pi. And look at this. Look at it, if you look at it little carefully, right? See this 2 and this 2 and then this 7. Yeah? If you write this 2, 2 and put a 7, this is what it becomes. Like a pi. Okay? So, anyway, so remember this is just a number, it's a constant which is given a name pi. All that is okay. This is just a refresher for the formula for area. Sandy and Sunil Vasundhara are very quiet today. All good? Are you okay?
Yes.
Okay. Now let's move on. So this, whatever I said just now, or whatever we looked at just now, that was just to do a refresher of the base that we will use. Now you look at something more funny. What do you see right now?
A notebook.
No, it's a rectangle. Yeah, it's a rectangle. Because you don't know what is there behind, I'm hiding it right now. Okay? Yeah? It's a rectangle, right? Now, what I have is, I'm putting a rectangle after rectangle after rectangle after rectangle, so many rectangles. What happened?
Just like kindergarten sketchbook.
Okay, let's not go into something which is out of syllabus. So what you're seeing here is, I'm putting so many rectangles one after another. And that is what made something called notebook, like Sani said. So when you saw rectangle, it was a shape with only length and width. Now when I put so many rectangles one after another, it got something called height also. So I had length and width, now I have something called height. If I keep on putting more pages on the top of it, it will keep on getting taller and taller and taller. I will need more space. Yeah? So my length and width are remaining the same. What is increasing is my height. Yeah? So whatever was a rectangle before became a new shape. Now if I draw it on the board, I had a rectangle before. I put so many rectangles one after another that it became like a brick. It is called cuboid. So if you look at a cuboid is nothing but so many rectangles of the same size stacked one after another, where length and width also now got height. And yes, Arya.
I'm sorry.
No worries. I was just saying that. So when you start so many rectangles one after another, you got added height also into it. You had earlier length and width, now you have height also. That is called a cuboid. Yes, Arya.
Could it also be called a rectangular prism?
Yes, I'm coming to that. So it's called a cuboid or rectangular prism. Okay. Similarly, now if you look at a square, you can stack one after another so many squares that you added height to it. So much, see, in the case of a square, your length and width are same. If this is length, this is also length. You added so many squares that its height is also same as length, okay? So if this was 5 centimeter, this is also 5 centimeter, and this is also 5 centimeter. This is called a cube. When you have length, width and height all same, that is a cube. All of you have grown up eating ice cubes, seeing ice cube, putting ice cube in water, putting ice cube in juice, milk, whatever, right? Cube is, mathematically if you see, ice cube is supposed to be an ice block of ice with 1 centimeter height, length, 1 centimeter width and 1 centimeter height. That is what is called an ice cube. Okay, that is how it is supposed to be. But unfortunately, you will see ice cubes made like this also, like a sphere. You will see ice cubes looking like an elephant also. I don't know what I am making right now, but yeah. You will see all possible shapes of ice being called as ice cube, but that is not mathematically right. Your ice cube is supposed to be like this. That was the origin, that's the reason why it was given the name ice cube. Ice, which is a perfect cube. Yep. Is everybody with me? So, this is cuboid, this are rectangular prism. These both are same. This is called cube. And practical example of cube, you guys, all of you who have played snakes and ladder or seen a dice, right, that you roll, which has 1 to 6 written on the back. I see friends getting busy. Okay. Okay. Alright. So coming back to this one. So this shape, which is called a cube, has all length, width and height same. And when you look at a cuboid or rectangular prism, it has length and width different and height being different. It's all different, okay? So that's why it is called cuboid, it is called cube. Now going back to what I was bugging you guys for, right? Area of a rectangle is length into width. Area of a square is length into length. But length into width, 2 dimensions, okay, when height comes into picture. Now imagine this cuboid or a rectangular prism as something that has originated from a square, rectangle. A rectangle, when you add height, meaning your area was length into width. Volume. Now coming back to this one. This has probably 50 pages. And this is this tall. What if this had 2000 pages? This would have been much taller. It would have needed more space. That is exactly what is called volume. What is the volume of any object? It is the space taken by that object. Okay? A three-dimensional or solid object. Now what is my volume? I am this tall, this is my size. So I am taking this much volume. If I gain, let's say 50 kilos more, okay, or 100 pounds more, I will need more volume. I will need more space. I will get bigger and bigger, right? So volume is nothing but the space taken by object. Now this rectangle will take more space when you are adding more volume, more height. So volume is nothing but area, the space on the surface times the height. That is what determines the volume. So volume of a cuboid. Cuboid is originating from rectangle. So area of rectangle times the height. Volume of cube will be area of a square times the height. So here the volume would be area of a base, length into length, square, times height. Height is also the same. So it becomes length into length into length. Is it okay to digest or sounding very difficult? No? Fine? Yeah. Sandy and Sunil very, very quiet today. What happened, beta? You both are always super active. All okay?
Yes.
Okay. So now, and again, we have not looked at anything complicated so far. So now how you will relate things? Let me put them into 3 buckets. This is the rectangle bucket. This is the square bucket. And this is the circle bucket. When I have a rectangle is what? Length into width. Area is length into width. When I add height to it, volume became length, this is width and this is height. Volume became length into width into height. Now look at the square bucket. The square is like this, where you have length and length. Length and width both are same. So your area was length into length. Again, what did I do? I had a square, I added height to it. length, this is also length, and the height is I also extended the height so much that it's same as length. So the volume is length into length, this is the area part, into height, which is also same as length. So this is the area of the base times height. Area of the base times height. Now the third one that I am talking about, this is called cuboid or rectangular prism. This is called cube, and this is called right. Okay, let me first draw it and then we'll give it a name. A circle. Take a circle. The bangles that you would have seen at home, right? Everybody is having. Okay, you guys have different chain, but you would have seen mommy having bangles, right? The round ones, like a circle. And if you put so many bangles one after other, you will see it becoming like this. If you put all the bangles together in the proper way, it becomes like a cylinder or like a glass. Right? So here we know the area of the circle is pi r square, where r is the radius. What is the volume of this one? Again, same thing here. You found the area of the base, multiply that with the height. This is the area of the base and this is the height. So it will be pi r square times height. Cuboid originates from rectangle, add height to it, becomes cuboid. Cube, origin of that is squared, you add height to it, the volume is area times the height. Right cylinder, your base is always a circle, keep adding more circle after circle after circle and add height to it. More circles you add, more the height, more the volume, more the space it will take. And that will be derived by area of the base times how much is the height. Is it making sense so far? Vasundhara, Advik, Arav. So there is a news for you guys. All the kids who are coming to the class, I am printing t-shirts for you guys. I mean, I'm not printing, I'm getting t-shirt printed for you guys. So the kids who are coming to the classroom, they'll get t-shirts. Kids who are not coming to the classroom, I have to find out what to do. So Advik and Arav, you guys have to figure out when are you going to come to the classroom, at least to collect the t-shirts. Okay. Alright. And for the kids who are being remote, I will find out something. Okay? Alright. So, and the t-shirts are coming next week, 17 to 21st. That's what they have promised. Let's see. So here, what did we see? So far we have dealt with two-dimensional shapes, where we are talking about length and width. Then when you add height to it, it becomes a solid. And we looked at three different types of solids. One is called cuboid, which originates from rectangle. Another one is called cube, which originates from square. And the third one is called right cylinder, which originates from a circle. Is this part clear to everybody? Clear as in crystal clear. Now, I'm tempted to take you guys to other shapes also, but I'm not doing that on purpose, because there's one more concept about it that I would want you guys to be aware of or think about. So volume part is okay, right? I mean, volume, from basic understanding point of view, volume is the space taken by anything. And we learned how to find out the volume of a cuboid, cube, or a rectangular, or a right cylinder, right? Now, there is another thing. When you look at a two-dimensional shape like this, a rectangle, Myra and Arya here. When you look at a shape like this, a rectangle, you are only talking about the area, meaning the space that it takes. And other thing that you would want to know is perimeter, the length of the boundary. This, and this. Yeah. But when you look at a three-dimensional object, you don't talk about area, right? Because area doesn't make sense. Which area are we talking about? We are talking about the volume, meaning the total space it takes. Yeah. So there is one more thing that comes into play, that is called surface area. Surface area. Yeah. What is the surface area? Surface area is the area of the surface. Now, if I say, what is the surface area of this guy? It is the whole thing, the curve that you see here, the bottom here, the top here, and even the area that is exposed here in the air, right? So anything that is on the surface, that is called surface area. Now, think about it. Let's say, if somebody says, find out the volume of this classroom, that will be the total space, length into width into height, whatever, right? Or if it's not like a perfect cuboid, we'll figure it out. If somebody says, find out the surface area of this classroom, what does it mean? Guys, pay attention to what we are doing right now. We have still 37 more minutes. Let's use that time effectively. So, if I say, what is the surface area of this classroom? What am I trying to figure out?
Trying to figure out how much surface is on in the entire classroom. So like you said with your water bottle.
Okay.
How much is exposed?
How much is exposed? Yep. Chandler and Sulain, what is your point of view?
I was about to say a similar thing.
And tell me one thing, why would I try to figure out what is the surface area of this classroom? Any idea?
Install like carpet or something.
So, will I install the carpet on the roof?
Oh, put it on the ground. Put it.
I mean, see, I'm not saying that your answer is wrong. I'm just making you guys think. What do you think, Sanilda? Why would I use surface area? Why am I trying to determine the surface area? Any reason? Say that again? Surface area. I'm talking about surface area. Surface area. So this is the surface. That is the surface. Even this is the surface. Yes, Arab.
Probable cause level to measure the surface area of a roof is so like if one of the thing is formed on the protective sheets or layers so the roof won't be destroyed.
Okay. So surface area again. So you guys are thinking in the right direction. Let's hear Saurya's point of view also. Yeah, Saurya, tell me.
You would also maybe want to know the area because like if you would like to maybe add some stuff in the room and you could know how much room you have left in the
Okay.
But you could need surface area because like if you are a builder, you need to tell your client how much surface area is in the entire house. So for that you need to add the surface area of all the rooms.
Right. So now, yeah, let's hear Arihan also. Yes, Arihan, tell me.
I mean, maybe if for whatever reason you were selling your house, then a buyer might ask, hey, what's the surface area of this?
Yes and no. Surface. See, they ask for carpet area, not the surface area. Yeah. Yeah, Dikshita.
If we are buying a house in the like the site, it like access like the length, height, and surface area.
Wait, I'll come back with the right example, okay? Do you guys see something? This is a page. Yeah? Now, kids who are coming to the classroom, they might say, okay, this class is looking very boring. We need to have some vibrant color. And I need to figure out, do I need to buy a paint box which is this small in size or this big in size? Would I need less paint or more paint? Right? To make the classroom look more engaging, more what you call vibrant, more positive to you guys. Right? I mean, my wife has been telling me for some time that you are teaching kids in the classroom where it should look a little more bright, so that the kids find it more, what you call, more engaging or more positive. So that is a side story. Let's keep it aside. But yeah, mostly you use surface area to find out what you would need to color it, to paint it, to cover it, right? Like in this whole surface area, if you look at the classroom, kids who have been in the classroom, you would know that okay, there is something called carpet area where I can install carpet or put like epoxy or something, and for the wall I would need to paint. So the surface area of the wall will tell me how much paint I would need, and the surface area of my floor will tell me how much of epoxy or carpet I would need. So here in the context of a 3D object, surface area is nothing but the total area of the surface. Here you see only one area, this area. Here what you see? This area, the area on the top, the area at the bottom, the area on this side, the area on the back. Total 6 sides. And in case of cuboid, what you see? This area and this area in the back, they look same. This area and the area on the side opposite to this looks same. Area at the top and the area at the bottom look the same. So area of a cuboid, surface area of a cuboid is 2 times the top area. I'm not telling you the formula right now. Plus 2 times the top area, 2 times the front area, plus 2 times the side area. Okay? And we'll determine this once you guys go a little older. Okay? I'm not trying to teach you guys everything right now so that I retire faster. Yeah? Alright? Likewise, if you look at a cube, you will see that it is made of, again, it has 6 areas. This area at the back, this area at the back, this area at the back, at the bottom. So you have total 6 sides. In case of a cube, all sides are same. So it will be 6 times the area of the front. That's it. Yeah? If you look at a right cylinder, what do you see? It has the right cylinder is here. Oh, I have a cylinder right in front of me. The same cylinder. This is the same right cylinder. This is also right cylinder, right? What are the surface areas you see? The circle at the top, the circle at the bottom, and then this curved surface that you are seeing here, right? So that is the total surface area. If you want to color this cylinder green, you have to color this top portion, the bottom portion, and the side portion, the curve. So that is the surface area of this cylinder. Again, I'm not telling you guys how to find it right now. That will make it little overwhelming to begin with. So I'm not telling you guys right now. But I have probably told this to Dikshita, Advik and Arav in the past. You might have come across the surface area of a cylinder in the past. But anyway, don't worry about it. We'll come back to it again. But conceptually I'm saying, this is what we need to understand when it comes to surface area or a volume of a 3D object. Or now, like Saurya was telling me, right, that can I call the cuboid as a rectangular prism? And I said, yeah, I will not deny that. It's the same thing. You had a rectangle, you extended it, you added height to it. It's rectangular. It was a rectangle, it became a prism or a cuboid. rectangular prism. Likewise, you will come across terms like triangular prism also. You have a triangle, you added so many triangles after another, added height to it. This becomes a triangular prism. How do you find the volume of this guy? Find out this area of the base and multiply that with the height. Everything, every three-dimensional object which is symmetric in nature, you find out the area of the base, multiply that by height. That gives you the volume of the shape. Is it? So this one is called what? This is made of triangle. So it's called triangular prism. Yeah? Is it okay?
Yes, sir.
Okay. Some of the kids who are missing, they will have to deal with the video to understand this, and if there is a question, they have the option of coming back to it. So this is on the very basic of the geometry that we wanted to learn. Then we looked at the volume concept, and then we looked at surface area also for some of the shapes. And we'll go deeper into it in the future classes. But we wanted to also start something called statistics. What is statistics? Yes, Aaron.
Statistics is a type of pretty mathematic query graph where we use data to imply of what we use mathematics.
Okay, any other definition? Arihan, Shaurya, Gayatri, Sandrine, Sulaim, Sani, Advik, kids in the classroom, anybody? What do you know about statistics? Give me a second, beta. Give me a second, okay? I'm hearing an answer. Yes, beta. Go ahead.
It's a specific number of data.
Okay. Okay. All right. Dealing with data. Okay. Let's see what Sami. Yeah, Sami. Complete your chain of thought.
Statistics gives you certain measurements in mathematics and breakdowns.
Okay. Let's see what Vasundhara says.
I think it's like analyzing data.
Okay. Shaurya.
It's kind of like you put stuff into a graph of like different types of data, then you analyze the question from.
Okay. Sandrine, Sulaim.
Analyzing data over a topic.
Okay. Dekshita.
Interpreting data.
Interpreting data. Mayra, Aryahi, Adya, last year. Did I say right? This way? Okay. Yeah. Asha is saying what to say. Yeah. Now I'm just trying to pick your brain, okay? What do we mean by statistics? It's a very interesting topic, and I promise I will not teach you guys anything here in statistics. Because it's a way to represent what we already know. Yes, Advik.
It's really how to collect raw data and you put them into like table like a pie chart or a bar graph, and you like analyze the graph to answer some questions or something.
Okay. So you guys have a fair understanding of what is statistics. Let me give you guys a journey. Okay. Let's say right now we have how many kids? 8, 9 kids, 10 kids on the screen, 5 kids in the classroom. I have 15 kids. Let's say I put everybody's age. Okay. I'm just trying to determine who is how old. Okay. And I'm not calling out names. Okay. Only my age is a matter of concern. Everybody else is fine. Yeah. You guys are 10, 12, 13 year old. I'm 49. So I'm not talking my age. I'm only talking about kids' age, okay, in the class. And last year thinking, this guy is saying, I will not tell my age. He has already told his age 2 times, 49. So anyways, coming back to the serious discussion. Let's say I am putting the age of all the kids, okay? And I'm just making it up, okay? Don't worry about it. None of this age is yours. Who is 2.9 in the level 2? Let's say these are the age of all the kids in the class. Okay? And don't try relating it to this one is mine. No. Don't even guess. This is the age of the kids in the class. Now when I look at this number, this is a number. Good. This is one age of one kid, this is age of second kid, this is age of third kid. This is good to have information. I have the information now. What can I do with this? This is just collected data. Everybody hold your horses. I'll come to you guys when I have to ask questions. What I'm saying is, when you see this data, this is called unstructured or unorganized data. From this data, you cannot make any sense out of it. You can just read this information. This is just data. This is unorganized or unstructured data. This doesn't help you give, or this doesn't help you get any insight into it. This doesn't help you find out something. This doesn't help you interpret anything. This doesn't help you derive any conclusion out of this data. Now let's look at this data. I look at this data, what I said, okay, fine. Age, number. I said 10 to 11 years old, 11 to 12.5 years old, 13 plus, 13 or 13 plus. Then I'm just making it up, okay? 10 to 11 years old, I have 5 kids. 11 to 12.5 years old, I have, let's say, 6 kids. 13 or 13 plus 4, I have 3 kids. I'm just making it up. From this data, I counted it. I said 10 to 11. 1, 2, oh no, sorry. 1, 2, 3. Okay, let me correct it. 3 kids. 11 to 12.5. So meaning more than 11 up to 12.5. More than 11. 1, 2, 3, 4, 5. I have 5 kids here. 13 or more. So 1, 2, 3. Okay, 3. This is matching. So now if you look at this data, yeah, change the data. One more. 1, 2, 3. Oh, 15. Okay, sorry, 4. Yeah, thank you. So now, when you look at this data, this is a little bit more meaningful. We had unorganized, unstructured raw data. We categorized them into some group. Okay, so this is when I'm organizing the data. This became organized data. Now if I make a chart out of it, to 11, I'm making a bar chart. And we'll learn this, again, we'll revise this. 1, 2, 3, 4, 5. Who is not able to hold the horses? Horses are ready to run. Hold it for 2 more minutes. Okay? Don't get super excited because I am planning to tell a story. Now, this is 1, 2, 3. Okay, this is 11 to 12.5, and this is 13 or 13 plus. This is 5 kids. This is 4 kids. Look at from here to here. This is a journey. This was unstructured data. You just collected some raw data. You organized that. That made it more sense. You made it more presentable. This whole thing together is called statistics. So statistics is the way to collect, to organize, to represent data in a way that it helps people interpret and make decision out of it. Was there a good punchline? Okay. Now, Arav, I stopped you twice. Now tell me what was your question, what you were raising your hands for.
So the graph you made, was that a histogram type graph?
I said it's a bar chart. It's a bar chart right now. And you said histogram. If you remember, see again, I'm not trying to rush for it. Histogram, there's a difference between bar chart and a histogram. When you see a histogram, you'll see things being contiguous. When you see a bar chart, these are skyscrapers standing next to each other with some gaps. Okay? So this is bar chart, this is histogram, but I did not have to explain that since you asked a question. Just wanted to make sure that you are clear about it. Everybody else in the class, just forget whatever I said. Okay? Because I will come to this. We will explain this. But right now, I had only one intent. I had only one plan to get the idea of statistics deep rooted in your minds. Why do we need statistics? Because all of us have data around us. Now, if you guys think about it, okay? Let's say, am I making everybody sleep? No, it's okay. It's fine. Just be comfortable. Now I'm just hoping that I'm not making it. You guys fall asleep, okay? Because teachers get boring at times. So what I'm saying is, now let's look at a situation. Yesterday, mommy made, let's say, 10 chapatis. Today she made 12. Day before yesterday she had made 14. 5 days ago she did not make even one. What is this? This is data. This also helps to determine some behavior out of it. That okay, if daddy has to go and buy the raw material for cooking, all this information that is coming from everyday's information, that helps daddy to determine, okay, how much of chapati we are making every month, how much of rice we are making every month, so I have to keep that much budget for it. Statistics help you tell that or derive that. All this raw data that we deal with every day, you use mobile phone, every day you are using mobile phone for 2 hours, you are watching TV for 3 hours, you are talking to friends for 30 minutes, you are walking for 1 hour, all this is data. Everything is information. If you collect all this information, store it somewhere, and then you realize it. Let's say each one of you get some pocket money, some gift from parents, right? And you use that in certain ways. Some of you use for buying books, some of you use for buying clothes, some of you use for buying slippers, sandals, shoes, some of you use for buying cosmetics also. Right? So how you are using that money over a period of time, all that is data. And when you structure it to derive some meaningful conclusion from it, all that is done by statistics. So statistics has 2 parts, or 3 parts rather. One is the data itself. Second is some methods for organizing the data, and then some tools for representing the data. So 3 things: the raw data, the method for dealing with the data, and tools for representing the data. That is where we will talk about bar chart, histogram, scatter plots, dot plots, graph, line graph, pie chart, whatnot. Yeah? And we'll talk about all that one by one. But from today's point of view, if you look at the boundary of statistics, it revolves around data. The information, data is nothing but information. Be it information about the power of my glasses, right? I started wearing glasses since '89. Now it is 2025. So I've been wearing it for 36 years. When I started, I had minus 0.25. That was my power. Now if I look at it, I have minus 3.5 power. So if I want to analyze how my power has increased over a period of time, so by the time I turn 60, how much my power will be, I can look at the data and extrapolate that. So that is what statistics helps you with. It looks at the raw data, uses some tools and techniques for organizing it, massaging it, and then some tools for repainting it, so that based on that information you can derive some conclusion, or at times you can extrapolate that for anticipating the future also. Yes, Harald.
So statistics also help with financial, so how your assets and liabilities.
Anything and everything that has information, right? So statistics doesn't have any limitation. That's what I was saying. Statistics could be around finances, it could be around even the houses life. Let's say in my neighborhood I have 20 houses or 40 houses. 10 houses are 10 years old, 5 houses are 8 years old, 20 houses are, let's say, 15 years old, 2 are brand new. This is the information. Based on that, the builder will say, okay, fine, in 20 years 10 of the houses will be out of life. So that those are the owners who will come to me for reconstructing it. So this is a business opportunity for me. And how will the builder build that thing? By collecting the data, massaging it, deriving some interpretation, representing it, and then looking at that information to extrapolate and find out a business opportunity. Yeah? So it has nothing to do with financial, it has nothing to do with how, it could be anything and everything which has information. Be it how all of us are growing with age, how is our height changing with time. That also is part of statistics. Right? All of you, when you were like 2 years old, this tiny, now everybody is growing with age. So you can look at a graph or a chart which will say, okay, fine, 2 years this height, 5 years this height, 10 years this height, 12 years this height. So by the time I am 16 years, this will be my height. You can make a guess around it, and that will be an informed guess, a more mathematical guess than making what do you call, uninformed assumption. Yeah. So that is what statistics helps you with. But the core of that is data. Core of that is data. One is data, the raw data. The data has to be right. Once you have all the information, then you have to use the tools for massaging it, to fine-tuning it, and then the tools that we'll talk through for representing it. So we'll talk about some of those tools in the coming classes. I mean, not coming classes as in future. We'll talk about some of the tools and some more examples of it in the class tomorrow. And then we'll do some more practice around it to see whether whatever we have learned with respect to statistics, is that relatable or not. And again, a request to you all, whatever you learn in this class, not only this class, I'm saying in the math class, whatever you learn, remember that there is a practical, relatable situation always. Be it with respect to statistics, be it with respect to trigonometry, be it with respect to geometry, be it with respect to algebra. Any topic that we learn, always think of where do you see the practical relevance of it. We talked about circle and right cylinder. I had the right cylinder right in front of me. Right? Circle. Imagine a life without a circle. There will be no cars, there will be no fans, there will be no air conditioners.
There will be no nails because their heads are flat.
Yep. Correct? Think of trigonometry or geometry. Can you imagine a door which doesn't have a shape defined? We talked about volume. If there was nothing called volume, this class was non-existent. Yeah? We had no place to live. We had no identity for ourselves itself. We are visible because we have volume. If we don't have, if our volume becomes zero tomorrow, how would all of us look like? Volume 0 means nothing. Will not be visible itself. Yeah? No height, width, length, nothing. 0. Everything height, width, length, 0. We all will look the same. Or will not be seen at all. Yeah? So what I'm saying is, whatever we are learning, you guys are one step behind preparing for SAT, right? Now what I'm saying is, before you get to that rat race of SAT, where 1520 versus 1550 versus 1499 matters, before you get there, I want you guys to engage yourself in math as a subject or as a life skill rather. Okay? Don't learn math because your teacher is forcing you to bear with him for an hour every Saturday, Sunday. Learn math because it's a life skill that you're developing which will help you being a better human being when you guys grow up. That was a speech. I'll let you guys go. Alright?
Bye, sir.
Alright, take care. Have a nice rest of the evening.
Bye, sir.
We'll bother you tomorrow same time.